a sumo wrestler decided to go on a special high-protein diet to gain weight rapidly. He gained weight at a constant rate, and 2 months into his diet, he weighed 225 pounds. And after 8 months into the diet, his weight was up to 304.2 pounds. And with this information, we want to be able to write to our linear model, but first we need to understand what we have been given in these couple sentences here. So we have that he's gaining weight at a constant rate, so it's staying consistent, meaning it's going to be linear. We also have that after 2 months, his weight is 225, and after 8 months, his weight was 304.2. This is telling us we have ordered pairs. So we have 2 ordered pairs in this setup. And we need to also figure out what is our independent and dependent variables so we know which to call X and which to call Y. And with this, the months is going to be the independent variable because that's not what he can control at all. That's just going to be going on in time versus the weight that is depending on how many months have gone by. So our ordered pairs are going to be month, comma, weight. Because they're always X, comma, Y. And we are having X be months and weight be Y. So our ordered pairs that we have, 2 months into the diet, he weighed 225. So we have 2, 225 for the first ordered pair. And then 8 months, his weight was 304.2. So we also have 8, 304.2. And now, using these 2 points, we want to find our slope M. That's going to tell us the rate that he gained weight each month. So M, that is equal to our formula, y2 minus y1 over x2 minus x1. So this is going to give us 304.2 minus 225 over 8 minus 2. So then that gives us then 79.2 over 6, which that can be simplified to 13.2. And then lastly, whenever we're asked to find a rate, usually we want to include units on that. So let's take a look at the units of our numerator here, the 304.2 and 225. Those are dealing with weight, so that's going to be pounds. And then we need to divide that by the units of our denominator, well, that was months. So this is 13.2 pounds per month that he would be gaining weight. Now we can use one of our 2 points to be able to figure out his initial weight at the start of the diet. So our equations, they look like our y equals mx plus b. We have our slope m, and we can put in one of the 2 points in for x and y to evaluate b. So I'm just going to use the first ordered pair 2, 225 because they're both whole numbers, makes it a little bit easier. So when y is 225, that is equal to 13.2 times x, which our x has to be 2 because we put in 225 for y, plus b. And now we can solve this for b to get our initial amount. So we have 225 equal to 26.4 plus b, and then we can subtract 26.4 from both sides. So this gives us then that 198.6 is equal to B. And now we can write our linear model. We know what M is and we know what B is. So our linear equation is y equal to 13.2x plus 198.6. And then now with this, the nice thing that we can do to check is since we were given 2 points, we can verify this a little bit better than what we did in the last example. But we can verify it by using the other point to make sure that both sides of our equation stay equal to each other. So the point that I did not use to find B was the 8, 304.2. So now I'm going to put that into this equation for x and y. So 304.2 equal to 13.2 times 8 plus 198.6. So now to simplify this a little bit, 304.2 is equal to 105.6 plus 198.6. And now 105.6 plus 198.6, those add together to give us 304.2. So both sides of our equation are equal, meaning that this point 8, 304.2 is on this line that we have written. So hopefully it should be correct. And then our last question that we want to answer here is, what is the wrestler's weight after 1 year? So now with this, we want to be a bit careful because our x is in months. So I don't want to just put in 1 for x because 1 year is not the same thing as 1 month. 1 year is equal to 12 months, which means I want to replace x with 12 in our equation. So we have y equal to 13.2 times 12 plus 198.6. And now when we evaluate this, you should then get 357. And this is our y, which has a unit of pounds. So after a year, we'd expect his weight to be 357 pounds.